Howdy again. Yeah, a new video of me, short after the last video of So Father So Son. But this time I'm going back to the polynomial issue, which I like to talk far better than the Palestinian-Israel subject, because it's a much nicer subject to talk about. But as you could expect, I did a polynomial approach and solving a higher than 2 or second order polynomial with a second polynomial parabola. And to show you that it also works for even higher polynomials, I did it also for a polynomial of the 7th order, and I'm going to show you that right now here. But I'm afraid that the resolution of my camera, which is just a simple Nokia mobile phone, is not high enough. So, but take my word for it, it works pretty well, and I hope to show it, but I estimate that the details will not be so great to see for you. Maybe I can enhance that a little bit, but well, let's start anyhow with what I have now. Okay, one moment. Okay, here, this is the 7th degree polynomial. Let's zoom in so that you can see it still nonetheless. So what you see here is, for example, this one. This is the 7th order polynomial, the thick blue line here, which goes all the way up, which is off screen and then comes down and then again and so on. This is the 7th order polynomial. The other curved figures like this is the parabola, which approaches the 7th order here close to 0, and this orange one is approaching the 7th order one close to 0, and this green one, which is a very pointy one, is approaching the 7th order close to 0 also here, and this one is brownish color, which approaches, which goes all the way up and then bends down and comes here at this point. And well, I get the same kind of result in approaching, and also here I forgot the blue line. This 7th order is approached in this point by a parabola. This parabola, light blue parabola, and so on, so on, so on. So you can each point you can approach by a parabola, and in a semi-exact way solve the equation. And I did that, as you can see here. Maybe you cannot see it in detail because the resolution of my camera is not so high. But okay, you can take my word for it. If you don't believe me, you can try it yourself. That to resolve these equations, and here you see a very zoomed in part of it, as well as this, and I tried several points, several how to say, trend lines with Excel. What I also found is that Excel is a limited program. It has some limitations, which is not in the advantage of this research or this search. And so in some cases you need to take my word for it that things are okay, but you can test it yourself. I mean, if you don't take my word for it, then yeah, you go ahead, play along with it yourself and find out that I'm right. So each zoomed in part is a very small part of the 7th order graph, and I approached it with a trend line, which is 2nd order or a parabola. And I used that one trend line, and I set it to 20 digits, as you can see, to 20 digits, and then I transferred it here. I copied it from here to here, and then I did the ABC formula to solve it. And then especially in this case, I exactly found exactly the same number as I have put in it. And well, also here I did it several times with different parabola approaches, with an r squared of 1.000, and here with an r squared of or this is a linear line. I try to approach it And here I approach again with a parabola with well, at least 10 or maybe 15 nines in the r squared, so it's a very good r square. And I can approach each point is another point, etc. So I always get a very good approximation, a very good number of what I'm looking for. And the error is in the PPT, parts per trillion area, the parts per million, parts per trillion area. So if I compare it to the original seventh order graph and I put that number into it, then I get an error not bigger than a part per million or part per trillion even. And also if I put in the number, which I of course I put it in, and if I know what I put in, so if I take that I refer as a reference, if I put that as a reference, then I get very high or very low errors and a very high resolution. So it's nearly exact. It's in a few ppts or few parts per trillion or even parts per quintillion. What is it? Of an error. So it's a very good way in resolving parts per quadrillion. I even have minus 47.5 parts per quadrillion as an error. Well, that's almost nothing. That's zero. So the approximation in this way of doing is very good. It's very good in approaching the whole stuff. And also here we have an approach. So yeah, it's also 99.5 parts per quadrillion that the error is. I mean, of course, it's an approximation, so you expect an error, and in this case, it's 99.5 parts per quadrillion. That's to the minus 14, to the power of minus 14. That's the error that you get in this approximation. So that's, well, kind of zero. Also here, is there another point? Yeah, here. Also very good resolution, very good way of finding and solving the whole thing. So yeah, this approach, this way of doing, here you can see this is a zoomed in part. Let's zoom out a little bit. This is zoomed in, but here it's a little bit more or less zoomed out. Here you can see an enlargement of it. It's only part of the seventh. Let me enhance the seventh order graph, so you can see. Yep. Please skip that. So now you can see this is the seventh order graph. I'm thickening the line so you can see it, enhance it. This is the seventh order line which I'm talking about. I can even further enhance it by taking a different x. Minus 15, I happen to know where it's from, so minus 15. So what is it? Let's say 30. Yeah. With 5. Yeah, let's do it like that. So, well, this is a zoom in again, but then a little less zoomed in than this one. It's the same graph, but even not so much zoomed in. Here you can see the parabola. Here you can see the parabola approaching and here's the other one. And here are two parabola in which I approach the seventh order graph. And it's turns out to be very good. I mean, this is seventh order graph, so yeah, it's fairly good to a way to determine a higher order polynomial, and it's crossing the x-line points. How to say, intercepts with the x-line. Yeah, so it works. It works. I'm happily pleased. I'm pleasantly surprised. I'm pleased. So I want to share with you this knowledge, and well, you can take advantage of it. I mean, now that I've proven the concept of using it for a higher order than 2, you can if the order is x to the 100 or 101 or the whatever kind of order. Now you can find it out. But this is one of the methods you can find it out yourself. If there are any crossing points where they cross the x-line, of course. And I mean, if it floats above the x-line or below the x-line, you will never find anything. Especially if it's an even function. So x to the second, x to the fourth, x to the sixth, x to the eighth. So then it may be floating above the x-line or below the x-line, so you will never find any crossing the x-line. But if it's an uneven, then at least you have 1 point, because then you always get something like this. One leg down, one leg up. So. Okay, this is what I want to share. Thanks for watching. Take your advantage from this knowledge and do your thing with it. Okay, hasta la vista. Thank you for watching. Bye-bye. See you next time.